Hi all, welcome to the fourth video. In this video, we'll quickly walk through whatever that's remaining in the processMazeFile function. So firstly, I'd like to make a quick edit to the algorithm here. So the vector of vector, which is used for maze, we inside the main function declare it. So just declare it, and whenever we call the function, processMazeFile, we will pass whatever the vector that we created. In addition, there are other arguments that we need to supply. We'll look about them, but first we'll make one quick edit to this, to these steps that we already have. So now that we have our maze vector of vectors, what we need to do is, whenever we loop through the file, read each line into a string, at that moment, we will add an empty vector into the vector of vectors. So inside the main, we are not doing much. We're simply declaring the vector of vectors maze. And we'll tell the compiler that it's going to be of character data type. But now when it comes to the actual processMazeFile function, it is where we can create these vectors. And we will create one vector for every line. So create an empty vector. And the way we deal with vectors is that we use pushback method a lot. So let's say maze is our vector. So all we need to do is to say that pushback and then define a vector of character types. And that's it. This will push an empty vector into the maze file. So once we have the empty vector, now we already have seen that strings are nothing but an array of characters. So iterate through each character and push back the character into the last vector in maze. So in addition to all these steps, it would really help if you keep a variable for tracking the number of lines read. So let's say create a variable, for instance, int I is 0 or something, so that you can keep this variable for tracking the number of lines read from the file. And how is this going to help? The way this is going to help would be, we can simply access whatever the vector that is most recently created in this manner, maze of I. So maze of I will give us the most recent vector that was created, and we can simply do push back whatever the character we have in the string. So in this way, we can populate our maze. And once we have all of our maze populated from the file, all we need to do is to call the print maze function and print the maze. So at this point, we'll be printing something. We'll be printing something like this. So this structure will be printed. Once we read everything from the file, what we can do while reading data from the file is, we have additional parameters here, which are start room and finish room. If we notice, for the maze, we're passing by reference. This allows us to save some time. We are not creating a copy for the processMazeFile function, but rather we are accessing the maze file that has been created in the main function. Similarly, there are two variables, start room and finish room. So I'd say that create these two variables of integer type, start room, and then finish room. These variables are going to help us keep track of where Jimmy is starting and where Jimmy is ending inside the maze in any given file. So initialize some values other than zeros or ones. So initialize them. And then whenever we are calling the processMazeFile, call this, and even the first file is at argument 1, which is the maze file, pass the start room, and then finish room parameters. So all along, this is where we are using the concept of pass by reference. So we are not creating copies for maze, start room, and finish room, but rather whatever that's created in the main function, we are making use of them. And now, once we have the start room and all the stuff, the way we are going to utilize is, whenever we are reading a file, or whenever we read a line from file into string, check if the first character is an underscore. Okay. If yes, then update start room. This is where Jimmy needs to start. And again, whenever we are reading the file into a string, check if the last character is an underscore. If yes, update the finish room. Now, one of the test cases in the handout, if it is, so somewhere there is a test case where we need to check whether a given maze has a finish room or not. I'm not sure. I may have forgotten that. Yeah, I think it is maze 6. So if we notice the maze 6 input, there is no finish room. So if a maze does not contain either a start room or finish room, whenever we are updating these details, let me hide this. Yeah. So once we parse through the entire data, once we are out of parsing through all the data, have some checks. Check if the start room and finish room are still -1. If either of them, so either start room is populated and finish room is not given, or if finish room is given but start room is not given, or if both of them are not provided, you may have to display an appropriate error message. So if either of them or both of them are not available in a maze file, print an appropriate message and then return false. So again, all the methods or most of the methods that we have here, they return Boolean values. So you have to determine what is the appropriate condition in which a method returns true and what are all the conditions in which a method returns false. So it's on us to understand this, go through the test cases, see the output, and figure out how or what each method should do. And to the most of the processMazeFIle logic is here. Up next, this is like we read whatever that's in the file, we populated our vector, we figured out where Jimmy is starting and where Jimmy needs to end the game. And then if there's any issues with the maze file or in opening the maze file, or if start room and finish room are not there, we are printing an appropriate error message and we are returning false value from it. So just be careful of all this. And now the most important part. Once the data from maze file is read into the maze. Maze is the variable name for vector of vectors. So once we read the data into the maze, now process the maze file. So when we say process the maze file, we handle this part. So for all first row, for all the elements in the last row, replace the X's with underscores. So these are the rules of processing. Okay. The first rule would be the first row or the first vector. When I say first row or first vector, it's the 0th index. So whatever that's there in the 0th index, it should be of underscores or hyphens, except the last element. And remember, whenever we access vectors, it's similar to arrays. This gives me the first vector. And maze of 0 means first element of first vector. So again, when I'm using the term first, I'm referring to index 0. So please be careful. And similarly, the last row or the last vector. So Vector has size function. Use the size to determine the last vector. So again, even the last vector, it should be of hyphens except the last element. So we are done with handling both the first row and last row. So once we are done with handling the rows, so the first row, the last row, both of them should be hyphens. So once we are done with that, now handle the third rule is handle the first and last columns. All the values needs to be filled with or symbol or pipe symbol. The exceptions are exclude the corners. I'm not sure corner. Yeah. Or not sure. Just to get the spelling correct. Exclude the corners. Exclude this one. Exclude this one. Exclude this one. And exclude this one. So exclude the corners. We have 4 corners. And start and finish rooms. So the fourth one, the start room should be filled with J. You know the variable that keeps track of start room. Use it to determine the start room. And the finish room should be filled with O. So all these things will guide you in the direction on how to read the contents of the file into a vector, show the vector, and then convert the vector into the way we need it for playing the game. And the last rule is excluding the first and last row, excluding the first and last columns, fill the remaining rows or fill the remaining elements with, if it's an underscore, if it's an underscore character, replace it with a pound, and if it's an X character, replace it with a pipe. So that's it. So these are all the things where we use to create the maze. And eventually, once everything is done successfully, print the maze. Also print the position where Jimmy is. So what is the start room? What is the end room? You have to print how many rows have you read from the file and how many columns have you read from the file. And also you have to print the modified image. We have already seen how the steps are there to print the modified image, and also print the current position where Jimmy is at. Always Jimmy will start from column 0, but we have to figure out the row number, and we have to print the modified image. And eventually, once we are done with the processing of the input image, the input maze file, before processing the input maze file, somewhere we have to print this header that we are about to handle the maze file. So this is how we handle the maze file. This is how we take care of the maze file. All these steps, if you go one by one, they will definitely help you in landing up with a correct logic for processMazeFILE. So that's all in this video for the processMazeFILE. In the next video, we'll talk about how we process the maze input file. Thank you.